Welcome to another exciting round of multiplying mayhem. I'm your host, Mayhem Matt. Let's get started. Well, today's topic is on trig ratios. We're going to see how we can use trig ratios to find things such as maybe like depth or distance. Now, Hope and I should tell you, we have a huge yacht and we use trig ratios all the time when we're docking our big yacht. Actually, Hope is supposed to be here helping me, but she's parking our yacht right now. Let's see the kind of progress she's making, if any at all. Well, it looks like it's going to take her a minute to park this boat. And by the way, that pool, that's not a backyard pool. That's on our top deck of our yacht. So don't be fooled by that. Anyway, enough of that. Let's meet our trig ratios and let's get started right now. Well, here's our three trig ratios that you may or may have forgotten about, since it might have been a minute. If you're returning to school, this will be a little refresher course for you. We know that our sine is opposite over the hypotenuse, and we know that the cosine is adjacent over the hypotenuse, and we know finally that our tan is opposite over adjacent. Now you're probably thinking to yourself, you, Matt, are wrong because there's 6. You are completely right. How do we get the remaining 3? Well, we just flip those suckers. The inverses, if you will, the hypotenuse over the opposite, and so forth and so on, all the way down until we have our 6 complete world-renowned trig ratios. World-renowned. Well, anyway, you get my point. Well, let's see what kind of problem we have today where we can utilize some of these trig ratios to solve said problem. Well, over here, you can see the SS Hope. It looks like she has docked the bow of the boat. And our anchor here, it looks like it's 30 meters long. Our anchor in this situation, though, is the hypotenuse. This X marks the spot where our anchor is adjacent to the seabed, which is this value, this length right here. Well, it looks like the only thing missing is the distance, and that's what we're being asked to solve for. So if we've got the distance and we've got the length of the hypotenuse and the angle, what trig ratio can we use to figure out how to solve this problem? Well, that's real simple, right? We know that the 39 angle and the distance are opposite of each other. So the opposite over our hypotenuse would be what? Right, it'd be our sine function. Sine equals opposite over the hypotenuse. So let's go ahead and solve for D right now. So let's set up D here. And D is just going to be D over, what did we say, our hypotenuse, which is 30 meters. And that is going to be equal to what? Well, it's going to be equal to 39 degrees, isn't it? All right, simple enough, isn't it? Well, we're trying to solve for D, but the problem with that is we see that it's being divided by 30 meters, right? How do we get rid of the 30 meters so that we can isolate the distance so we can solve for distance, which is what we're trying to do? Well, inverse operations, you knew I was going to say that. Let's multiply both sides by the 30 meters, right? So that's going to look something like this, isn't it? 30 meters divided by over here. Okay, we've got 30 times D divided by 30 meters. These two 30 meters, what do? They cross out, leaving us with D, which is what we're trying to get in the first place, right? Well, now we've got to multiply the 30 meters by our 39 degrees over here, and that's going to be simple enough because all we're going to do, if you've got your handy-dandy calculators out, put them in radian mode and hit sine 39 degrees and then the 30. And that is going to give us the decimal equivalent of that. I'm not going to go through that. I'm just going to give you the answer, which is like 18.88 meters. So our distance is 18.88 meters. And I see that 88 is a little jacked up here, so let's make that a little bit neater. Or if you prefer foot, that's going to be a 62-footer in length. That's our distance from the bow of the SS Hope to the seabed. But hark, as Hope and I are trying to pull out of port, we're accosted by some wild pirates. They tell us that if we can figure out the remaining value of this angle and this angle, they will let us keep our looty, our booty, our belt. I'm not really familiar with the vernacular of the high sea terms, but anyway, we get to keep our goods if we can figure out the remaining angle values of these two. Well, can we do that without the trig ratios? You know we can, and we're going to do that right now. How will we do that? Well, let's look at the kind of triangle we have first. We know that we've got a right triangle, don't we? Why do we know that? Because right here. And that is 90 degrees, isn't it? We also know that the value of all these angles in a right triangle add up to what? Yep, 180. So what do we do with that? Well, let's go ahead and make 180 equal to 39 degrees, plus our right angle, our 90, and that's going to be plus x. And x here is this value up here, the unknown. We already got two of the angles solved, don't we? Okay, simple enough. Well, we got 180. And what does 39 and 90 add up to? Yep, 129 plus x, our unknown. Trying to get x by itself right, we need to solve for x. How do we isolate x? Well, why don't we just subtract the 129 from both sides? You knew I was going to say that, inverse operations. And let's take 129 away from 180, leaving us with 51 equals x. And it looks like this degree here is 51 degrees. I apologize for my handwriting, but we could add up the 39 and the 90 and the 51 to double check our work to make sure it comes up with 180. But you know Matt Mayhem, he never makes a mistake, so I don't have to check it, but you might have to. Well, that's all the time we have for here on Multiplying Mayhem. You've been a wonderful audience. I'm your host, Mayhem Matt. We'll see you next time here on Multiplying Mayhem.